Welcome to Topic 1, Principles of Nutrition, Physiology and Health, Lesson 2. Today we're going to be looking at carbohydrates. We're going to be looking at unpacking their functions in the body, also looking at the different types of carbohydrates, how we classify them, and each one's sort of specific makeup and role within the body. So let's start off with like a general overview of carbohydrates. So when I say carbohydrates, a lot of us think of pasta or bread, but also remember that simple sugars are in like lollies and chocolates and peanut butter and fruits. So these are also filled with carbohydrates. So carbohydrates are basically sugars and fibers and starches, all made up of different formations of the same molecule, or molecules, if that makes sense. Now, I have said this before and I will say it again, that carbohydrates are the body's preferred energy source. I know that in the previous video we talked about lipids providing the most energy per gram, but carbohydrates are the body's preferred energy source. So the body will use carbohydrates first, even though lipids provide the body with more energy per gram, carbohydrates are used first. And remember that carbohydrates provide the body with 17 kilojoules per gram. So, carbohydrates consist of the elements of hydrogen, carbon, and oxygen. And these elements are combined in specific ways to form the structures of saccharide molecules. And now we can classify carbohydrates into two major categories. So it can be simple or complex. Now I've color-coded these on the screen for you to see that the green is the simple carbohydrates and the blue is the complex. So with simple carbohydrates, we can further categorize these into monosaccharides and disaccharides. They are simple as they only consist of one or two molecules, saccharide molecules. Complex, again, can be further categorized into oligosaccharides and polysaccharides. Now, oligosaccharides you probably haven't heard of much before, but don't worry, we'll get into them in a little short while. So the key takeaways from this slide or from this part of the video is just to understand that carbohydrates are made of carbon, hydrogen, and oxygen. And that's why sometimes we label them as CHO, okay? Sorry. And you can categorize them into simple and complex, and we'll get into the rest now. So again, I've just categorized them so you can see simple are green and complex are blue. All right, so monosaccharides are our first simple sugar. And we're talking about glucose, fructose, and galactose. Now, monosaccharides are small molecules. They consist of only one saccharide unit. And I guess for me, they're the easiest to remember. I like motorbikes and cars and stuff, but if you're on a bike, a BMX bike or a motorbike and you chuck a wheelie, it's also called chuck a mono because you're on one wheel. Mono also means basically that it only contains one saccharide molecule, okay? So it's a form of carbohydrate that we consume every day, okay? They're a simple, so it's a hexose sugar, so hexoses. Simple sugars with 6 carbon atoms and the formula of C6H12O6. Okay, glucose to most of us is known as blood sugar or just your normal sugar, and it's essential in providing the energy for most of, if not all, of the body's everyday activities. Fructose, which is the next one in blue, it is the sweetest of the 3 monosaccharides, and its chemical arrangement stimulates the taste buds on the tongue to produce a sweet tasting flavor. Cool, right? Fructose gives honey its naturally sweet flavor. So when you taste honey and it's really, really sweet, fructose. Galactose is only naturally occurring in a small number of foods, and it generally doesn't taste like anything at all. You may look at the word galactose and notice that GA, if you take that away, it's lactose. Super important in the next little bit of the video. It will be important that you remember the chemical structure of the monosaccharides and more importantly, the differences between each. You'll notice that the only difference between glucose and galactose is the location of the hydroxyl group, so the group that has the H and the O, on the fourth carbon atom. So you can see glucose at the top, the hydroxyl group is down the bottom of that fourth carbon, and galactose, it is on the top of that fourth carbon. Cool. Now, when I was in high school learning nutrition, my friends and I came up with a sort of way to remember the different monosaccharides. I've come up with one of my own. It's not that cool to remember. If you guys want to come up with your own as well, that would be awesome. So monosaccharides, GFG, so MGFG, my goats fly good. It's lame, but I'm sure you can come up with something that interests you or is something a little bit more worthwhile to remember. All right, disaccharides. So similarly to monosaccharides, their name also makes them easy to remember. Now, the word di at the start of this disaccharides word is derived from ancient Greece, and it means two or double. Hence, disaccharides contain two monosaccharide molecules. It is important to remember now which monosaccharide molecule pairs with which to form these disaccharides. So to form a disaccharide, as you can see on the screen, a condensation reaction occurs and links two monosaccharide molecules together. A hydroxyl group from one molecule bonds with a hydrogen from another, and these form a water molecule. The two once separate molecules are now joined by an oxygen atom or an oxygen molecule in the middle. Okay, so lactose, which I'm sure we have all heard of before, is the first disaccharide, and it is naturally found in the dairy group. It's a combination of the two monosaccharide molecules, glucose, and you guessed it, hopefully, if not, it's on the screen. Anyway, galactose. Lactose contributes to half of the energy content of fat-free milk. Cool. It's the only carbohydrate that does not come from plants. Also a fun fact. Now, sucrose is a combination of fructose and glucose molecules. Remember, fructose is the sweetest monosaccharide and therefore provides sucrose with its sweet tasting nature. Sucrose naturally contributes to the sweetness of fruits, grains, and vegetables. Now, maltose is our lucky last disaccharide that we'll be talking about, and it consists of two glucose molecules bonded together. You may not have heard of maltose very much. It's sort of present in the fermentation process and like malt beer and things like that. So it's formed when two starches are broken down. Okay, and that sort of contributes to maltose. So these are the disaccharides. Remember, di equals 2. I also came up with another way to remember disaccharides. So DLMS, dogs like many snuggles, which dogs, cute, you know, one way to remember it. It's up to you how you remember disaccharides. Oligosaccharides. So oligosaccharides are larger molecules consisting of between 3 to 10 monosaccharides. I'm not going to go into too much detail about oligosaccharides. We'll talk to them more when we look at starch-resistant carbohydrates. But oligosaccharides are found in like your breads and cereals, your vegetables, your legumes, nuts, and some fruit. Okay, and that's oligosaccharides. Remember, whilst they are a complex sugar, it's between 3 to 10 monosaccharides. So they will take that a little bit longer to break down, but not as complex as polysaccharides. Let's talk about them now. So polysaccharides are large molecules consisting of several 100,000 joined glucose molecules. And in a separate video, I'm going to talk about all the different types of polysaccharides. We're going to get into really a lot of detail with starch and resistant starch molecules, soluble and insoluble fiber, and glycogen. So head on over to that video next, or watch this one again and take some notes, whatever you want to do. Thanks.